to ask questions. But today, I wish to talk to you about, I'm going to address the reason why we want you to ask questions. And the reason is very, very important for you to understand. Okay, so first, why ask questions? As soon as you have one. Okay, why you need to ask questions as soon as you have one. Okay, as I talked about it earlier, that this class is really 5 classes in one. Okay, in the olden days, okay, before AB 705, that legislature item was approved, right? So let me write it down, AB 705. The classes were taught differently. Okay, why they taught differently? Because you're taking one class after another. And typically you will be taking classes in the following order. Okay, so I'm going to show you that order. Some of these courses may sound familiar to you because AB 705 has just been implemented for about 2 years, So the first class you'll be taking is probably pre-algebra. And typically we call that Math 23. Math 23. Okay, then I'm going to talk about the contents, okay? After pre-algebra, the next class you're going to take is going to be beginning algebra. Beginning algebra. Okay, that's our Math 40. And we also have a different version of it, like Math 40, 43, right? And after that class is going to be intermediate algebra. Intermediate algebra. D-I-A-T-E. Intermediate algebra. Okay, that's typically called a Math 73, 70. These are the names being used, or 80. 80 is being the one that sometimes covers more materials because that's designed for people who are going to go through the STEM track. Okay, so after intermediate algebra, typical trajectory would be college algebra. College algebra, that's Math 130. Okay, and after college algebra, then we're gonna suppose we, let me just put rows. Okay. College algebra should be here, right? And after college algebra, the student will need to take a trigonometry. And that's our typical Math 170. Okay, I want you guys to have a clear view about what kind of task you're taking on yourself by taking this class. Okay, so I'm doing the recording right now, and I'm going to make this a specific section just to explain to you what it is you're doing. And after trigonometry, okay, and some student will take, so let me insert rows. Okay, so that's going to be pre-calculus. Okay, and of course you understand that just a Math 180. In the past, what was going on is that You take one class after another because each one of these classes takes 1 semester, right? You take 1 semester pre-algebra, you learn a bunch of things. What you learn? What do we learn in pre-algebra? Numbers, right? Sign numbers. So I'm going to put the contents over here. Okay, just so you have some idea about what I'm talking about, right? Because as we get into the semester, you start to see these contents in your study, right? So the contents of study in pre-algebra, right? It would be like sign numbers, okay? Fractions, okay, including percent, right? So what would you be doing? You've done plus, minus, multiplication, division. That's what you do in pre-algebra. That's pre-algebra, before you take algebra class, right? In beginning algebra, so you spend a whole semester doing that. You spend a whole semester doing that. You dedicate like maybe 10 hours, depends on your backgrounds, right? All right. The next course, beginning algebra, you're going to learn about lines, right? You're going to learn about factoring. So for example, you're going to learn about mx plus b, right? You're going to learn about factoring. And you're also going to learn about quadratic, factoring, solving equations. Okay, so this is a quadratic. Okay, with a is not equals to 0, right? So you have learned this. Factoring was a major part of that course. Factoring is a major part of the course. Now, after beginning algebra, you do intermediate algebra. Intermediate algebra has a heavy part is review the first two. Okay, so in intermediate algebra, I have taught all of these courses. Okay, so review the previous two, right? And we're gonna add some stuff. Okay, add some maybe long division, right? Add long division, complex fraction, complex fraction, yeah. Complex fraction, I would just make it a rational expression. Okay, rational expression. And what else? Root function, there will be some square root functions, and there possibly be absolute value that probably was introduced by that time. Okay, absolute value functions. To review, I should try to make these. Okay, just make it shorter. Okay, add a long division, rational expression, and rational expression, a complex fraction, right? Complex fraction. So you have all of these things, and the power, right? Exponent. You should have learned exponents already. Actually, you have these in exponents is also taught in this course in elementary algebra, EXP. Okay, you also learn that. Okay, so let me put it here. So there's a lot of repetitive. There's actually lots of repeat and reviews in those previous courses. So I'm just summarizing it roughly, right? Sometime if you take Math 80, if you have taken Math 80, right? In the recent years, I taught Math 80 multiple times. Math 80 actually could involve exponential function. Okay, exponential function and a logarithm function. So there's a variation. I know you guys' backgrounds are very different, Very, very different. Okay, so if you guys didn't have that, right, by the time you get to college algebra, you're going to have that exponential logarithm, right? And also there's some other, other stuff, maybe conic sections, etc. Okay, you guys have seen this, right? You guys see that? So when in our current, what we're doing here, you see glimpse of stuff that you learned from before, from various courses, right? So next is trigonometry. 170 is trigonometry. That's a 1 semester course, 1 full semester course with 3 units. So I've taught that class multiple times. Last semester, my Math 170 got canceled. Last semester, my Math 170 class got canceled. Why? Low enrollment. Low enrollment. Very few people enrolled in that class. Why? Why? Because everybody want to get quick finishing their academic courses, and they all swarm into pre-calculus. Some of my students skipped trigonometry entirely. They just go to pre-calculus. There's nothing we can do to stop you from doing that. Okay, so we cannot tell you anymore that you have to take some prerequisite courses before you take trigonometry. So that's how our trig class was canceled. As a matter of fact, I was not the only one. And I, as far as I know, there's another colleague of mine. His trigonometry class got canceled. And prior to that, I taught trigonometry twice in recent years. And I have taught all of these courses. But what I see here is everybody try to get to their exit courses as soon as possible. These days, few people, not as many people, they're taking these elementary courses. Okay, so we're going to address these issues later. So trigonometry basically cover, the 8 functions. The 8 functions, okay? The 8 functions you saw in basic 1 table. Okay, the last 8 functions. Okay, the last 8 functions. So if you have not taken trigonometry, you can totally register for my class. Nobody can tell you no. But you may not have seen sine, cosine, tangent, cotangent, cosine, arcsine, arccosine, arctangent, arccotangent. So when you will find that the last table, the table basic 1 looks very strange to you, the last 8 functions. Okay, but that's a very heavy duty course material that you have skipped. Now, all of these people, you can register for pre-calculus. Now you're with me. I have no idea. I don't know if you guys need help with trigonometry, because you are going to use trigonometry a lot because your target course, I assume is Math 190, right? Math 190. In Math 190, you're going to use all of these materials. Okay, you're going to use all of these materials covered by these courses. Okay, you're going to use all of these materials covered by these courses. But I understand you want to get down soon and then you can move on with your life. But the thing is, when you're taking this class, this is what you're dealing with. You're dealing with 5 courses in 1. For that reason, pre-calculus used to be a 5 units class. Now we added 2 more units to we call support class. So this support class is basically supporting the pre-calculus material. At the same time, anything and everything from pre-algebra, beginning algebra, intermediate algebra, anything we need that we think that we know that you might need is going to show up. Because you're going to need all of them for Math 190, Math 191, and Math 220 and linear algebra differential equation, you name it. But pre-calculus is not entirely a review class, but mainly it's a review course. It's a review course. Review all. And in addition, we're going to add a math induction and lots of other things like a polar, parametric, etc., etc. And maybe conic sections if you didn't have that before. Okay, so pre-calculus class is a review for all and get you guys ready for calculus and be successful. You understand? Be successful, not just getting in, you want to get out. So when I'm in the olden days, you just take one after another, say when you take college algebra, I can assume you already know these things that I learned before. When you are taking, say, beginning algebra, right? So professor who teaches beginning algebra can assume our student know how to add, subtract, multiply, divide fractions. We can assume that. When you're taking intermediate algebra, because you have taken the prerequisite course, otherwise you cannot register, and therefore we can assume you know how to factor, you know how to solve quadratic equations, at least the simple ones. Now we cannot assume that anymore. So anybody can walk from the street, anybody off the street, you can come to us and say, hey, I'm going to take pre-calculus, teach me. So we don't know you guys' background completely. We're completely in the dark. So I'm not speaking for anybody else. I basically is prepared for myself that to jump into any topics at any depth. So if we're doing something, we need to go back to pre-algebra. We need to go back to pre-algebra. If we need to do, adding fractions, we're going to do adding fractions. If we need to do multiply fractions, we're going to go to that. We were not going to be talking about, oh, this is pre-algebra. This is no. We're going to put everything together. Do you guys understand? And I don't know what you guys know, what you guys don't know. Because we cannot assume anything anymore. And this certainly showed up, right? It's not your fault. I understand the system. We just have to work the system and make it and be successful, really. All right, so this is the major, this explains why you need to ask questions. Because when you ask questions, from your question, I can detect that, what you know. And sometimes some of you may find it boring that you already know the stuff. Sometimes somebody might look at something, they've never seen that before. So this is the situation as a teacher I'm facing. And this is a situation as a student, right? Even though you don't see each other physically, but in an online situation, what you know, your classmates may not know. What you don't know, your classmate might know. Okay, but all the questions you have, I assure you, you are not alone. Because we're covering all of these materials all at once. I certainly cannot go back to teach each course in the length that was given for that course. Okay, these days, the enrollment of our classes on these courses are low. Like I said, my trigonometry class was canceled because of low enrollment, because people want to get out of college quickly and they take pre-calculus. And what often happens is that people have to realize, I don't know, it's very much a personal decision. And we're not supposed to give you advice, to make it, we're not supposed to make a decision for you, right? And at the same time, you have to perform. How much say do I have in the process? I would say very, very little. So my job is just to try to make it work. So this is why I'm asking you to ask questions as early as possible. As I'm thinking about this, right? Yesterday and over the last weekend, we got questions. You guys, if you notice the Pronto, right? I'm very excited to see you guys use the Pronto so much. But we got these questions, right? We got these questions. What are the meanings of greater than, less than, greater than, equal to, less than equal to? Okay, nobody should feel embarrassed because there's nothing personal, because we don't know who knows what anymore. Okay, and another question is that what are non-negative numbers? What's the difference? What's the difference between non-negative numbers and the positive numbers? Okay, so these are the question comes up. What I'm trying to say, when you have these questions, please ask as early as possible. Don't wait until when you're taking the quiz. Okay, because these words were addressed in the lecture. Do you guys understand my point? Okay, these words were addressed in the lecture. If you, one thing you can get these questions answered is you Google online. You probably get some information, but if you're not sure, just ask me. Okay, and so you can see this is reflected. These concepts, these questions were addressed at beginning algebra level, but you don't know. That's okay. That's okay. What I'm trying to say here is that during the lecture time, if you catch any word that you don't understand, please ask me to clarify. Don't tell me, oh, I'm confused. It's confusing. That doesn't help. Okay, just tell me what and where you're confused. Could you guys do that for me? I want you to understand the whole situation we are all dealing with. It's not just me, all the other math professors, we're dealing with the same issue. We can no longer assume, but we don't know where. We also has to start somewhere. Okay, so let's address each one of these issues. Okay, so now, what is greater than? Well, this symbol, right? This symbol, it means is greater than. Is greater than. Okay, for example, we can say 3 is greater than 2. Okay, so this symbol is a shorthand notation for is greater than. And the other symbol is less than, is less than. Okay, for example, -2 is less than 5. Okay, so this symbol represents a phrase which is greater than, and this is less than. How about the other one? Greater than or equal to. Is greater than or equal to, not and. For example, okay, for example, we say a number greater than or equal to 0. What does that mean? It could be greater than 0, which include, 0.5, 2/3, 1, 2, 1.7, right? It could, and it also include 0, okay? Less than, this symbol means is less than or equal to. For example, I can say x is less than or equal to 0. What does that mean? What's the difference between x greater than or equal to 0 versus x is greater than 0? The former include 0. Okay, include 0. And all positive numbers. And this one does not include 0. Okay, it includes all positive numbers. Okay. This symbol, I see a symbol right there. Okay. This symbol means belongs to. For example, if we talk about a set, I have a set. Right? I have a set of number. I have a set of 1, 2, 3, 4, 5, 6. Okay. Number 1 belongs to that set. 1 is a part of the set, meaning part of. Part of. Okay. Any other questions? So any question, every question you have, there's no stupid question, there's no small question, there's no big question, there's no stupid question at all. Any question, just bring it on as early as possible. As early as possible. Okay? And I'm committed to help you to clarify those things. If I don't know the answer, I will seek out help from other people. And the other thing is, I don't want you guys to sit and wait. There are a lot of literature, there are a lot of information online you can look out there. For example, what's the difference between positive number and non-negative number? Go find out. If you have any doubt, bring it to me. Bring it to Farouz, right? Bring it to Farouz. We'll help you. Okay? That's about this one of these questions we encountered over the weekend, which I think is paramount. We need to clarify that. We need to make sure you know it. The other question we encountered last weekend is, what are non-negative numbers? What is the difference between non-negative numbers and positive numbers, right? So here we already answered, right? These meaning all the non-negative numbers. Okay. So now, even though that question is answered, all the positive numbers, of course, it's all positive numbers here. And this means all non-negative numbers, right? Or all non-negative numbers. And you can see these two symbols are not entirely the same. When I was making the quizzes, I just want to make sure you understand everything we did in class, which you need to watch it over and over. You guys follow me? You need to watch over and over. You do. Okay. And as you're watching it, you can't just say, oh, I'm gonna just watch. You're not going to be able to follow if you just watch. You have to have paper, pencil with you, sit in a quiet place, not much distraction. You can pause and watch and go back. That's how you have to study. I really cannot tell you there's any much easier way to do it. You have to put your thoughts into it. I'm not asking you to put it into your heart, because I know you guys don't love math, right? You don't love math. Few people love math. But I'm with you. I don't love math still myself. I can deal with it. Okay. All right. So for that reason, because the question we have here, I'm going to talk about the number system today. Okay, I'm going to talk about the number system here. So we just talk about why you should ask questions, because we don't know what you know. We cannot assume what you know. Okay, but I'm committed to help you in any way I can, any way I can. And you need to understand the task you're taking on yourself. Okay, if you don't prepare these courses well, if you don't review this course well, you're not going to make it 190. Even you can make it in, you cannot make it out. You may end up to take it multiple times. Then you may just as well to make sure you understand these algebra. Without proper algebra preparation, which are all these 5 courses included, it's impossible to do well in calc. This has been tested over and over again. Okay, this has been tested over and over again. Anyway, without further ado, and next, today I want to start by talking about number system. Do you guys have any questions about number system? Do you guys think I should address this issue? Number system? We have some interesting stories to share too. All right, number system. Thank you for your response. I'm glad. So I know you are there, right? I'm not such a nosy person. I don't want to just check on people and make people listen to my lecture, make people listen to my blah, blah, blah. But it's nice to know you guys are there, because some people actually, some of my students, they cannot make it to class. They watch the recording. That's all fine with me. Okay, that's all fine with me. But since you're here, I want you to benefit fully from this live lectures, so you can ask questions, all of that stuff. Okay. Anyway, without further ado, okay, we human, we know about numbers in time, right? For example, in the early days, we only know counting numbers. Counting numbers. So what are counting numbers? It's just 1, 2, 3, and so on and so forth, right? And today I got 2 deer, and tomorrow you get 2 elephants, and the next day you get 1 dog, right? 5 chicken, 3 turkey, and whatever. So, people, whatever they can hunt, they will just count, right? They learn a system to count. And these numbers, they're called Arabics, right? They're the Arabs. The Arabs discovered, well, they invented these numbers. Is that right, Farouz? Farouz is
Yes, ma'am.
And I'm sure the Arab heritage, you guys should be very proud of this fact, right? You guys made this writing so much easier. Okay, there's so much history. I would refer you to some videos, and I'm gonna, if you guys are interested in watching the videos, there's one of the videos by a historian by the name of Niall Ferguson. Okay, look for his name. He wrote he wrote a book called A Cent of Money. The Ascent of Money. Sorry. the ascent of money. Okay, and he has this title, and he has a TV program for it. You can watch it on YouTube. Okay, in this YouTube, he talked about how these numbers changed the life of Europeans. Okay, because before this, right? For example, Italians in that time, at that time, though, like city states in Renaissance time, right? People learn about the Romans used to use 1, 2, 3, and can you imagine to use these things to add and subtract? Can you imagine that? Can you imagine that? When I was a little kid, my mother, did I tell you about my mother? My mother was never much educated. But she will call these numerals Arabic numbers in Chinese. Okay, my mom was very little educated, but she will address these numbers as the Arabic numbers. And before the Chinese discover, learn about using these numerals, how the Chinese write their numbers. So I'm going to show you, right? This is our 1. That's number 1, 2. Okay, 3. Okay, and 4. This is a 4. And this is a 5. So it starts to change. But no matter what you do, you look at this. Look at these 1, 2, 3, 4, 5 in the Chinese way, and look at these way in the Roman way. How do you add them, subtract them, multiply them, divide them? So do you see that the Arabs contributed so much to our number system? It makes the adding, subtracting like a child's play by Niall Ferguson. He addresses this episode of the numerals in the history of humankind. It's a great contribution. But anyway, without further ado, right? You look at the Chinese way of writing it. It's just impossible to to do the operation, adding, subtracting, multiplying, division. Forget it. Okay. So with that said and done, so counting numbers. So even counting numbers evolves, right? So finally, we adopted this Arabic numerals. Now we call it just numerals, right? We just call it numerals. What would be the right way to call it? You guys, give me some clue. We just call them numbers, right? Numerals. So I recommend you guys to watch this program. This just YouTube Niall Ferguson. He's an amazing historian. And watch The Ascent of Money. Okay, so counting numbers, right? And so people will learn to add, subtract, multiply. And I think in the early days, people didn't do much of division. They might, or the division will be pretty simple division. Okay. And then I don't know when. Okay. And I will encourage you guys to find out. 0 is discovered. 0 is discovered. The discovery of 0, we have a story for it. I have a story for you. Okay, I have a story for you, but just 1 second. So 0 and counting number will be classified in another category we call whole number. Whole number. Okay, so whole number include 0 and counting number. And we also give another interesting name for counting number. We call them natural number. We call them natural number. All right. Now we discover 0. And so this the discovery of 0 is a big event. It should be a big event in the history of mankind. Okay, there's a book. I found the book. In my first class, I didn't find the book. Okay, the title is this. You guys see this? You guys see the book?
No.
Not. I'll write down the title. Okay, you see there's a book in front of me, right? You guys see the book in front of me?
Yes.
Okay. This title of the book is called 0. Someone wrote a biography for 0. Okay. And the title is called 0, the biography of a dangerous, look at my terrible spelling. Dangerous idea. Okay, the biography of a dangerous idea. I didn't finish the book, so I cannot tell you the whole story, but I'm going to tell you some stories about this book. Okay, I acquired this book for quite some time, but this time on a Christmas party at USC. Okay, I was sitting next to I think he's a fairly famous movie director. But to my embarrassment, I don't know him. I don't know he was so famous. Okay, and his name is not it's not Steven Spielberg. It's the other name. His name is called. Let me send it to you. Okay, this guy. I'm gonna send it to you pronto. Okay, we're gonna make today's lecture a little bit fun. Yeah. So we talk about something related to math, but has some other elements. Okay, let me see if I can send this to you. This is his name. Do you see that? There he is. His name is Christopher Trollman. Does any one of you know him? Anyone know him? Elijah, no? You know him? No? Okay, some people know. Some people know him. So he's quite famous, but he's not as famous as I don't know, right? He has some fame, so he made some movies. So he was sitting next to me. We were at this Christmas party, and he and his wife and me and my husband. So I was sitting there next to you at the USC, the former presidential mansion. Okay, it was a memorable Christmas holiday party. So he was sitting next to me, and he was a very nice, smooth guy. Once he knew that my profession is a math teacher, and he mentioned that he read a book. This book is titled 0, Biography of a Dangerous Idea. And I should feel embarrassed because I didn't finish the book. Right? And the book seemed to talk about the idea of 0 caused panic attack in the Catholic Church. How it happened, what happened, I don't know. I cannot give you enough information. I read a little bit some years ago, and I forgot. I forgot too much about it. So I have the copy, right? But anyway, and I was asking him, what movie he made, and he was telling me the names of movies. And one of the movie, I think he has a collaboration with some, overseas movie makers, and called Santi or something like that. It sounds like Chinese sounding name. But anyway, without further ado. So he probably has quite a fame, overseas, okay, in internationally. But without further ado, so this is a story related to zero, guys. Okay, this is a story related to zero, right? Zero is a very important number. We haven't get the chance to address it. So today, yes, we do. If you look at the 6 mathematical principles, how many of them are related to zero? Get your flashcard. You should have 6 flashcards on the 6 mathematical principles, right? 6 flashcards. How many of them has something to do with zero? The second one, anything adds zero stay the same, right? The 5th one and the 6th one, number 5, number 6. 3 out of 6 mathematical principles has something to do with zero. Isn't zero so important? You tell me. Yes. So with zero, with the introduction of zeros, we got some other goodies. Because zero basically becomes the point of reference, relative to, right? Below sea level, above sea level, sea level. Sea level is zero, above sea level will be positive, below sea level will be negative, right? So zero is a number that marks the relative positions. On the number line, the origin to the right, they're positive number. To the left, they're negative numbers. But is zero positive or negative? No, zero is neither positive nor negative. It is a neutral number. Zero is a neutral number. And with the introduction of zero, we get into another category. We call them integers. Integers. So what does integer include? Zero. Zero is included in integers. Okay, in the future, when you do programming, right? In the program language, they would very commonly they use int as one category of numbers when you declare your variables and stuff. Okay, and +1 -1, +2 -2, sign numbers. So with the introduction of zero, sign numbers are introduced. So you can see whole number include a natural number, but we have a little bit more. Zero is the more, that's more than natural number. So the difference between whole number and natural number is that whole number has zero, natural number does not. So whole number includes zero, natural number does not include zero. Do you guys follow me? Integer include all of these and more, because in integer we have introduced negative numbers. So once we get integer, we humankind has a very good reason to celebrate, don't we? Do we have a reason to celebrate? We kind of take it for granted these days, right? I'm sure that hundreds of years ago, people might have a party for it. These days, who's having a party for the discovery of a new number? Only those nerdy mathematicians, right? They have a pi day every year. You know, Marie Calendar, they give you a piece of pie on Pi Day. Have you heard of that? Have you heard of that?
Yes.
Pi Day. Did you take advantage of it?
Yeah, my math teachers would always bring pies to class on Pi Day.
Good for you. All right. And next. So, you know, zero is so important. I promise you a number. I promise you a story, right? Zero is believed to be invented by Indians, not American Indians, the Indian Indians. Okay, how was it invented? Are you ready for the story? Yes. Okay. Imagine on the weekend, you're going to the beach. I think most of us are pretty close to the beach, right? 30 minutes, 40 minutes, 20 minutes to the sand, right? And you bring a boiled egg, hard-boiled egg with you because you're going to eat that hard-boiled egg when you get to the beach. Yeah? Imagine this scenario. You put that hard-boiled egg and you put it in your bag and you get to the beach, you get your umbrellas and you get everything. By the time you get to the beach, you find a spot and your egg dropped to the sand. And you pick it up and you eat. But please, before you eat, look at the mark the egg left on the sand. Doesn't that look like a 0? Yeah? No more eggs on the sand, right? So in meaning and in symbol, that's how 0 is invented. The symbol of 0 is invented. Okay, I like the emojis, you know, on the chat. Thank you for your response. Okay. So in meaning, that mark is true because there are no more eggs in the sand, but it leave a mark. That mark is 0. So that's how that symbol 0 get into our human language. Across the cultures, across the nationals, the national borders, this symbol is so powerful. It dominates the mathematical principles. And it continue is a dominant figure, dominant number in our number system. It's huge. 0 is a huge symbol. Okay. Anyway, without further ado, we have 0, right? And what do people do with these numbers? They had a party. Had a party. We love it, right? What can we do with these numbers? You can't eat them. You cannot drink them. What do? We add them, we subtract them, and we multiply them, and we divide them. When we add, subtract, multiply, divide, we discover some new numbers. Why we discover some new numbers? If you add 2 integers, you still get another integer, right? You subtract 2 integers, you're gonna get another integer. You multiply 2 integers, you're gonna get another integer. But when you divide 2 integers, what happened? Sometimes you get an integer, sometimes you don't. What happens if you do 2 divided by 3? What happened? And all of a sudden we freak out. Oh my God, 2/3. It's not an integer. We had a panic attack, but at the same time, as we just calm down and we realize we have discovered, we have invented, or whatever you say it, we have discovered a new category of numbers. And this new category numbers, we call it rational number. Okay, rational number. How is rational number defined? Rational number is defined one integer divided by another integer, provided the denominator cannot be 0. That's how rational number is made. Rational number also has another name called fractions. So fractions are rational numbers. Rational numbers are fractions. It's just people like to call that name. Then you say, why rational number? Because, well, if there's rational numbers, you may ask, do we have irrational numbers? And the answer is yes, we have irrational numbers. Maybe for that reason, we introduce rational numbers instead of just use that plain fractions, you know? Who knows? You know, you don't know what's going on in those nerdy mathematicians' mind, right? I don't even know. Anyway, without further ado, so what are irrational numbers? Right, so we have fractions, right? So what are irrational numbers? Any number that is not rational, it is irrational. How do you like that definition? Well, there's a deep meaning into it. Any number that cannot be represented by one integer divided by another integer, that's what it means. Are there a number that cannot be represented by one number divided by another number? Yes. Examples such as pi, e, we talked about the other day, right? What else? Square root of 2. And so on and so forth. How many are there? Infinite. So if you look at the number line, right? There's a German philosopher, and he's also a mathematician. He has proved the numbers, all of these numbers, rational, irrational, and all together we call them real numbers. They are everywhere dense on the number line, i.e., every real number you can find a place. Okay, on the number line. So rational numbers, irrational numbers, and all of these together make the real numbers. And the question is, you know, they have also proved, besides rational numbers and irrational numbers, there are no other numbers on the number line. Therefore, on the number line, any number you pick is either rational or irrational. And all of these numbers together, they make the real number. And they are everywhere dense on the number line. Okay, everywhere dense has a specific mathematical meanings, concise mathematical meanings. For you, you just imagine there's a number everywhere you poke on number line. Between the numbers, between any two numbers, you're gonna have a number. Between any two numbers, you name it, however close they are, there will be another number. If you think that 2.1 and 2.2 are close enough, between 2.1 and 2.3, there are infinite number of numbers between them. Can you imagine that? Okay, so this is our number system. And you may ask, how about complex numbers, right? How is a complex number introduced? Are we gonna deal with complex numbers? For you, before you finish your calculus series, most likely you're not gonna be dealing with much of complex numbers. But complex numbers is an important category of numbers. But what introduced the complex numbers is actually this. Okay, remember we talked about square root function somewhere down the road, right? The square root function. Right, we take square root of any real number, right? And we say the domain is greater than equal to 0, i.e. if x is negative, we say it is undefined. We says undefined. Now the question is, why is undefined? Why the square root of a -1 is undefined? Because if there's anything here, right? Suppose that there's a, I'm going to put a symbol here. This little symbol is not going to be a real number. We cannot find it. We cannot find it. Therefore, the sign that we have discovered a new number. So we're going to call this basic unit I. So I is the major reason, well, is the sole reason that we introduce complex numbers. And with the introduction of I, we can take square root of negative numbers, and that will be an entirely new system. We saw complex numbers. All the complex numbers assume this form, A plus BI, where A, B are real numbers. So complex numbers include a real number, but real number does not. So real number is only part of complex numbers. Do you guys follow me? Yeah, you got it? So this is our number system. So when you look at the number line, you need to think of the number line as everywhere dense. Everywhere dense. Every number you can think of, you can find a place and more. Between any two different numbers, there are infinite number of numbers. That's what number line, that's how number line is. Are rational, irrational on the same level? Yes. Because rational, it's very good, rational and irrational, they're on the same level because you can see rational numbers include all of these, right? But irrational numbers and rational numbers, they don't have anything in common. They're kind of on the same level, yes. All right. And for you guys, okay, you're going to be working in real numbers for a long, long time. You don't have to worry about complex numbers. Complex numbers has its own theory. We call it complex theory. It's an advanced course for student major in mathematics in his or her junior years or senior years. Now, I took a complex analysis in my junior years in college. Okay, so you don't have to worry about that for a long, long time. Okay, so just be with me on real numbers, would you? But you do need to know about irrational numbers because you deal with them. All right, shall we take a break? And we come back, we're going to talk about, you know, how to find inverse functions and stuff like that. All right, so let's take a break for 10 minutes and come back at 12:30. I'll see you soon. I need to get something to drink.